Sorry about that. Miss out, plan ahead. So I wasn't watching the time. Okay, so I was cut off mid-sentence. Let's go back to this example or this, for instance. So we were talking about rational polynomial functions where the coefficients are rational numbers. Okay, so that would be like something if we name that is an element of Q as rational numbers. All right, last one. They're calling it a real polynomial function. Now, if you look, we've got a rational number, we've got some integers as well, but this one right here, the square root of 3, that is not a rational number, it's not an integer, it's actually an irrational number, so it would just come under the category of real numbers. So coefficients are real numbers. And really, that's the case with the other two as well, but you name it for its most restricted part, okay? All right, let's take a look at the next page. Okay, so let's put all those definitions that we just learned to use. In each case, write a polynomial, p of x, satisfying the following conditions. So we want to come up with a polynomial, p of x, so p of x equals, that is a trinomial, that means we have 3 terms, a quartic, which means degree 4, and integral means the coefficients are integers, okay? So no fractions and no square roots. All right, so let me think. 3 terms, degree 4. So I'm going to start with a degree 4 term. My integer needs to be an integer, or sorry, my coefficient needs to be an integer. There we go, 5 would work. You could put as many terms as you wanted. You could go down to x cubed, x squared, whatever. But we do have to have 3 terms, right? So I'm going to throw in, say, a minus 2x, and then I'm going to throw in a constant term, say plus 10. Okay, so I have 1, 2, 3 terms. It's a trinomial. Degree, highest exponent on x, is a 4, and my integer or my coefficients are integers, positive or negative whole numbers. Good. Why don't you guys come up with a polynomial, and our answers aren't going to be the same, but as long as they satisfy these 3 conditions that are given for B and C. Okay, pause your video and give that a try. Okay, let's go over. Now there's certain things that have to happen on these polynomials. So first of all, binomial, you must only have 2 terms. Linear means your highest degree on x can only be a 1. Okay, and then finally, real means our coefficients have to be real numbers, but of course, these ones are real numbers, but we have to make it not integer or not rational. So if I put the square root of some number that doesn't have a nice square root, as long as it's not negative, that would satisfy the real coefficient aspect of that. Okay, next one, mononomial. That's 1 term, okay? Quadratic means it's degree 2, okay? So I have to have a squared on my x, and then rational means I have to have a coefficient, and I only have 1 term. Coefficient is a rational number, or a fraction. So you have to make sure your coefficient on x squared is some sort of fraction. Okay, hopefully that went well. Let's take a look at example 8. All right, evaluating unknowns in a polynomial function. Well, these examples, well, especially the first one, it's just making sure you know your function notation stuff, right? So remember from the first unit, if we're given p of x equals negative 3x squared plus ax, don't know a, plus 8, and we're asked to find p at 1, actually more than that. They're telling us p at 1. So remember, it's like p of x usually, so they're telling us x is 1 when p at 1 is negative 9. So that's like your y value actually, or your p of x value. Okay, so let's put this to work. P at, they said 1. So everywhere you see x, you need to substitute 1 in. All right, so we run through, scoop x out with brackets, and substitute 1 in. Okay, let's simplify that. So negative 3 times 1 squared is going to be negative 3 plus a plus 8. Okay, and then simplify that a bit more, a plus 5. Okay, but we know also that p at 1, this here, is equal to negative 9. So guess what? We can actually replace that with negative 9 and then continue solving for a, because that's what they're asking us to find. So solve for a, or isolate a, by subtracting 5 on both sides, and we would get a is equal to negative 14. Woohoo! Got it. All right, next one. Example 9, last example on this lesson. Determine the values of A and B, okay, so two unknowns this time, in P of x equals negative 2x squared plus ax plus b if P at 2 equals negative 18 and P at negative 3 equals negative 13. Okay, so what I would suggest, because you're going to do most of this, okay, plus ax plus b, write that down twice. P of x equals negative 2x squared plus ax plus b, okay? You're going to use these bits of information, okay, once and then twice to determine an expression or an equation that has a and b in it. So you guys go ahead and do that. Pause your video and basically go as far as you can. You're going to have A and B, you won't be able to go any further, and then unpause your video and we'll take a look where to go after that. Okay, so we substituted 2 in for x, and then P at 2 was equal to negative 18, so that replaced P at 2 on the left-hand side, simplified as much as we can, and got all the constant terms on the left-hand side, so we ended up with negative 10 equals 2a plus b. Did that with the other bit of information, and we got 5 equals negative 3a plus b. Okay, we can't go any further with each of those, but we do have 2 equations and 2 unknowns, so guess what? Welcome back to, is it grade 10 or grade 11? 20-1 or 10C? I think it's 10C actually. So we have a system of equations is what's going on here. So we can solve by, solve by substitution, okay, or we can solve by elimination. All right, so you know they both have their strengths. I'm just looking, I noticed that substitution would be easy enough. If you isolated b and then replaced it over here, that would work. Or we could do elimination and subtract the 2 equations. But you know what, for the sake of practice, let's actually isolate b here. So we're going to subtract 2a to the other side, and we'd have negative 10 and then minus 2a. Now we're going to replace b over here then with what that is equal to. So b is negative 10 minus 2a. Okay, let's simplify that. We have 5 equals, sorry about that. 5 equals negative 5a minus 10. Okay, and we can solve for a now. So add 10 to both sides, and then divide both sides by negative 5. And we should end up with a is equal to negative 3. Okay, awesome. Now that we have a, we can replace that back into this other equation. So negative 10 minus 2 times a, which is negative 3, and we would have negative 10 plus 6, which is going to be negative 4. And there we go. We found our a and our b values. Okay? And that would be solving a system using substitution is what we did there. We're going to have another situation like that in a later lesson, and we're going to use elimination probably if we can. So we'll get some practice at that. All right, hopefully you're ready to do lesson number 1 now in class tomorrow, and thank you for listening. Good night.